Everyone, welcome back to my YouTube channel. So in today's lecture we'll be continuing with the bitwise operators as well. So as we left off in the previous lecture, we'll be starting off with the left shift operator. Okay, so it is symbolized with two less than signs. Okay, and the normal syntax is your variable number, your variable name, left shift operator, and the value n. So this n can be like any integer. Okay, so n is an integer which will be used to perform the left shift action. Okay, oh yeah, the eraser is big, I think. Okay, anyways, so what left shift operator does is ki it shifts the bits n times to the left. So yeah, this is the basic definition. It shifts the bits n time to the left. Okay, so this is an integer. It can be 1 2 3 4 or whatever. Okay, so by n times to the left means ki n bits from the starting will be dropped off, and instead of them n bits will be added in the rightmost of the your binary number, and all will be zeros. Okay, so okay, at times. Okay, yeah, so if I have my x value is 0 0 0 1, okay, and I do x left shift operator 2. So as I said ki this left shift operator shifts bits to left, shift n bits to left. Okay, I need to write it more clearly, so I'll just remove this one. Okay, shift n bits to left. To the left. Okay, this is n. Okay, now fine. So I did x left shift operator 2. So as I said ki it will shift n bits to the left. So all these bits will be shifted to left side by 2 value. So in just to remember it like in a easy way, so starting n bits will be dropped off, and the rest n bits will be added in the rightmost part, and all will be 0. So this x mod 2 will give us the value 0 1 0 0. So I said ki these two like leftmost bits, n bits will be dropped. So I dropped these, I wrote 0 0, and then I said ki n bits will be added to the rightmost. So I added n bits to the rightmost, and all are zeros. Okay, similarly if I have x as 0 0 0 0 0 1 1 1 1 1 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, I'll just add 1 in the front. Okay, and now if I do x left shift, let's say 4 now. Okay, so what will happen, these 4 will be dropped. Okay, these 4 will be added as it is. So it will be 0 0 1 1 1 1 1 0 0 1 1 1. So as we have removed n bits from the leftmost part, and n was 4, so we will be adding 4 zeros in the end. Okay, so this will be the new answer. Okay, okay, then now moving to the right shift operator. Okay, right shift. Okay, actually I have to clear this up and write it again, because I am told ki right, please have a good rating, so I'm trying. So okay, right shift operator, this is denoted by 2 greater than signs, and the syntax for is x right shift operator 2, or like as I said earlier, n. Okay, so it shifts n bits to the right, shifts n bits to the right. Okay, so if my x is 0 1 0 0 and I do x right shift 2, okay, so my answer will be so the rightmost n bits will be shifted, okay, to the right. So the rightmost n bits will be removed eventually and they will be added in the front. So if this gets removed, my answer will remain 0 1 and I have to accumulate these two removed bits, so I'll be adding it in the front, so it will become this. So my 0 1 0 0 0 1 0 0, if I do a right shift operation on this, so my answer will be this. Similarly, if my x is 1 0 0 1 1 0 4 5 6 7 8 and I do x right shift 4, then these 4 will be removed and for the removed digits same number of zeros will be added in the front. So the answer will become 1 0 0 1 0 0 0 0. Okay, so now let's test this in our compiler. Okay, so I believe this is a little bit confusing. Okay. Shift inputs. Okay. Let's move over to the compiler. Okay, so as I said, first we'll be doing our left shift operator. So 1 left shift 2. Okay, so from the examples in my code, one, like I'll comment this, 1 is basically 0 0 0 1. Okay, and as per the left shift principle, it should become 0 1 0 0, which is 4 0 1 2. So actually I'm assuming you have knowledge about how to convert binary to decimal, so that's why I'm moving forward with this. Okay, if you don't have knowledge about it, so you can just read it somewhere how to convert binary to decimal and decimal to binary. Okay, anyways, if I'm doing left shift operation on my decimal number 1, so I should be getting 4. Okay, so now if I run it, the answer is 4, so this is correct. Okay, and now vice versa, if I if I do right shift operation on 1 right round, so the answer should go to 0, because as per the right shift principle, the rightmost digits will be shifted towards the right, so it will become 0 0 0 0. Okay, and now if I run this, see 0, and now if I do right shift operation on 4, so it should give me 1. So you can see over here 0 1 0 0, the right shift operation 0 0 will be removed and it will be added in the front. Okay, and this will be like whatever like it will become 0 0 0 1. Okay, so yeah, for right shift operation 2, it will become 1. So basically this is the right shift operation, as I said na, ki this will be removed and it will be added in the front. So actually what is the case is ki I told you na, ki the binary numbers are of 16 bits, right? 0 0 1 1. Okay, so if I'm moving it towards the right, so these two are getting removed and getting added in the end, right? So similarly, if I'm doing the right shift operation, these will be removed and these will be added over here. So it's basically like this only, okay? And if I had like if I had 1 0 over here, okay, if I do the left operation, then this will be removed. If I do the right operation, this will be removed, and 0 0 will be added over here. So I hope ki you have understood the left shift operations and right shift operation of bitwise operators. Okay. If there are any doubt, please don't hesitate to reach out to me through comments. I'll be happy to help you guys. And please like to my channel, and also subscribe to it, so that I get a little bit motivated on making all such videos, like not just on Python, and on various topics as well, various other topics as well. So yeah, thanks for watching my video, and have a very nice day. Bye.